Artificial intelligence is pretty much everywhere now, quietly making huge decisions that affect our lives, everything from getting a loan to getting a job. But what happens when these incredibly powerful systems start learning our own all too human biases? Well, today we're going to pull back the curtain and take a hard look at algorithmic bias. And hey, before we jump in, if you want to keep up with the tech that's shaping our world, do me a quick favor and hit that like button, and definitely subscribe so you don't miss our next one. It makes a huge difference. Thanks. Okay, let's just get right to it. Think about this for a second. Your next job application, that mortgage you're hoping for, maybe even a critical medical diagnosis. Could an algorithm be making an unfair judgment about you? This isn't some far-off sci-fi idea. It's happening right now. The big question is, are these systems making these life-changing calls fairly? So to get to the bottom of that, here's what we're going to cover. First, we'll break down what bias in a machine actually is. Then we're going to wrestle with the surprisingly tricky question of what fairness even means. After that, we'll see how you can actually spot bias, cover the 3 main ways to fix it, and wrap up with the really tough part, deciding which kind of fairness to aim for. All right, let's kick things off with part 1, the bias in the machine. We need to be super clear on what we're actually talking about here. So look at this definition. The key word here is systematic. This isn't about a one-off glitch or random mistake. Think of it like a crooked carnival game. It's designed, maybe unintentionally, to favor certain people over others, over and over again. It's a repeatable error that consistently gives one group a leg up and puts another group at a disadvantage. And let me be clear, this is not just some academic debate. The stakes are incredibly high. We are talking about decisions that can change the entire course of a person's life. Are you approved for a mortgage? Do you get that job? How long is a prison sentence? It's even being used in medical diagnoses. These are massive decisions. Okay, so if the problem is bias, the solution is just to make the AI fair, right? Easy. Well, not so fast. This brings us to our next section, because defining what fair actually means, that's where things get really, really interesting. So to even start measuring fairness, we have to know what we're measuring against. That's where this term comes in, a protected attribute. It sounds technical, but it's really just a way of saying these are the characteristics, like race, gender, or age, that we as a society have agreed should not be used to treat people differently. And the second piece of the puzzle is the favorable label. Again, fancy term, simple idea. This is just the good outcome. It's the yes, the approval, the thing you want. It's getting the loan, landing the job, basically winning the prize that the algorithm is handing out. Okay, now check this out. Fairness isn't one single idea. You can split it into 2 main camps. On one side, you've got group fairness. This is the big picture view. It asks, are men and women, for example, getting hired at roughly the same rate? Then you have individual fairness. This zooms way in and asks, if 2 people are nearly identical on paper, should they get the same outcome, no matter what group they belong to? And here's the catch. These 2 ideas can sometimes be in direct conflict. And if you thought 2 was a lot, it goes way, way deeper. Researchers have come up with, and this is not a typo, more than 21 different mathematical definitions of fairness. Each one is a slightly different flavor, a unique way of looking at what it means to be equitable. And this right here, this is probably the most important and frustrating truth in this entire field. It is mathematically impossible to make an algorithm that satisfies all of those 21 definitions at once. Trying to make it more fair by one metric will almost always make it less fair by another. You are forced to choose what kind of fairness you value most. There's just no way around it. So, if we know that perfect, all-encompassing fairness is off the table, how do we even begin to measure how unfair a system is? Well, that's where we get practical and talk about the audit. So, out of all those metrics, most of them boil down to asking 2 main questions. First, are the outcomes equal? This one's pretty simple. Are different groups getting the yes at about the same rate? But the second question is just as critical. Are the error rates equal? Because if an AI is way more likely to make a mistake when judging one group versus another, that is a massive, massive problem. Let's look at 2 really common ways this gets measured in the real world. First, you've got statistical parity difference. All you do is subtract the success rates. So if 80% of one group gets approved and only 60% of another does, your difference is 20%. Simple. Ideally, you want that number to be 0. The other one, disparate impact, uses a ratio. Same example, you divide 60 by 80 to get 0.75. In this case, the perfect score is 1. They're just two different lenses for looking at the exact same problem. Okay, so we found the bias, we've put a number on it. Now what? How do we actually fix this stuff? That brings us to what you can think of as the AI fairness pipeline, the 3 main ways to fight back against bias. You can think of this like building a house. You've got 3 different stages where you can intervene. First is pre-processing. This is all about the foundation, the data itself. Before the model even sees it, you go in and try to fix historical imbalances. Number 2 is in-processing. This is during the construction. You actually change the algorithm, telling it, hey, I don't just want you to be accurate, I also want you to be fair according to this metric. And finally, you have post-processing. This is like the final inspection. The model is already built, it's a black box, but you can tweak its final outputs to make them more equitable. So how do you know which one to use? Well, it all comes down to a really practical question. What do you have control over? If you can get your hands on the original raw data, pre-processing is a great option. If you're building the model from the ground up, you can build fairness right into it with in-processing. But if all you get is the final answer from a system you can't see inside, well, then you're limited to post-processing. And that brings us to our last section, and maybe the most important one. Because after you strip away all the code and the numbers, you're left with something that isn't a technical problem at all. It's a deeply human one. We already know it's impossible to satisfy every definition of fairness at once. That means choosing the best one isn't something a data scientist can just figure out from a spreadsheet. It's an ethical choice. It's a social choice, and it has to be based on the real-world impact these decisions have on actual people. So here is a powerful way to think through that choice. Ask one simple question. Is the AI's action going to help someone or hurt someone? If the action helps people, like offering them a spot in a useful training program, then the worst mistake you can make is a false negative. That means missing someone who really could have benefited. But if the action hurts someone, like denying them a loan, then the worst mistake is a false positive. That's unfairly penalizing someone. The context completely changes what kind of mistake you're willing to tolerate. And that's really the bottom line. This challenge isn't just about getting smarter with our code. It's about looking in the mirror. These algorithms are going to reflect our values, whether we're intentional about it or not. So the final question isn't really for the programmers or the machines. It's for all of us. What kind of fairness are we going to choose to build into our future?